Hello, President Peter. Uh, this is Clinton. I'd like to answer for your questions that you put forward in your video. For your first question regarding my learning experience without any instructions or textbook, so I took an additive manufacturing course for which we had a project. Uh, the requirement of the project is to select a product and redesign it for additive manufacturing. So I selected a robotic arm for this project, and the process I selected for this printing process that I selected for this product is fuse deposition modeling, which is shortly called as FDM process. And so, in order to print anything using the FDM printers, we need to use a software which communicates with the printer. So, there's a software called Catalyst, which asks you for the printing parameters to be set in it before the printing can happen. So, the so to determine the printing parameters optimal values, what I did is I conducted a DOE experiment. So we had three printing parameters that mainly affects the print quality. That is, they are layer thickness, nozzle temperature, and print velocity. So these three parameters should be set in an optimal condition so that the print quality is better. So in order to determine that, I conducted a DOE experiment, full factorial experiment. Since there are three factors and three levels, there was totally 27 runs. So I printed out 27 test pieces with each settings, and those 27 test pieces was tested using tensile testing machines. And so based on the results obtained from the tensile testing, I was able to determine the optimal printing conditions, which gives a maximum strength. So these conditions determined out of these, the DOE experiment was used in my project. And for your second question regarding my experience in building something, so for this project, as I said, I selected a robotic arm, and the arm that I selected had a different drive mechanism compared to what I redesigned. So the original arm was having a gear drive mechanism to operate the end effectors, whereas I redesigned the original model with a different mechanism. So as you see, it's a slider mechanism. So I eliminated the use of gear drive mechanism. So here, so in order to do this, I used finite element analysis to check the stress concentration areas in this product that I designed, and I eliminated the maximum stress concentration areas by doing optimizations. And I also did topology optimization to remove the weight of the product, and the final end product has a half weight compared to that of the previous original design. And here, so while printing this product, I had few defects in the process, such as delamination, inter-road voids, shrinkages, and staircase effects. So if you see, each of these defects has some root causes for why it's happening, right? So I determine each of the root causes, and I try to eliminate each defect as I go from one printing to next printing. So I had a total number of printing as 5 repetitions in order to arrive at this final end product. So if you take staircase effect, it's a common in all rapid prototyping methods, as your product is being sliced by the software before it's fed into the printer. So if you align the product rightly and align and orient the product rightly, it's going to slice in the same plane of axis, and it can eliminate the staircase effects. So like this, for various defects, I also like eliminated those by undergoing a root cause analysis for each of the defect. And so regarding your question, so you asked what I liked about this process. So in this process, I was able to go beyond the boundaries of normal conventional manufacturing techniques. So if you see in conventional manufacturing techniques, it's normal to use any metal fasteners to join the to create a joint. So I pushed beyond this boundary to arrive at this product where there is no metal fastener. The whole product was built at a single printing process. So I eliminated those metal fasteners by use of these custom designed pins, and the whole assembly was built by printing in a single repetition. So I like this about the additive manufacturing process. And the thing that I disliked in this process is that the experience I gained as I came through each stage, if I had that in the beginning, I could have done this project much in a much better way. And for your third question, uh, regarding my experience in training people, and what is the training tools that I used. So in my recent job as a grader and research aide, I teach undergrad students on how to operate lathe and perform basic machining processes. So for this, I created a training module which comprises of the safety procedures to be followed, and what is the chip removal mechanism in each process, and and how what is the procedure to do each process. So for this, I used videos from YouTube, um, to tell them what is a safer way to be at the lab, and what to do and what not to do. And for the chip removal mechanism, I created a slide on my own, based on the principles stated in a book called Advanced Manufacturing Technologies. And so after going through these training modules, they had a assessment. So it is just to check whether they are technically strong, and whether they know the safety procedures. So once they get through that process, I trained them and I demonstrated them how to do each operations, like milling, turning, and other stuffs. So this is how it went. Thanks for an opportunity. Hope you like my answers. I would like to hear back from you soon. Thank you.